circuit, capacitors can be arranged in series or parallel or combination of them. So, generally there are two types of arrangement of capacitors, either in series or parallel. Arrangement of capacitors. Either in series or parallel. Okay, how's the series arrangement? Okay, like this, C1 and C2 and C3. C1, C2 and C3 connect to the power supply. And arrangement in parallel. So this is C1 connect to C2, connect to C3. So they connected to the power supply. Okay, arrangement in series. C1, C2 and C3 connected to the power supply. Okay, so this is V battery or V power supply. Okay, now what will happen when all these capacitors are connected to this power supply? So charge will flow in the circuit, right? So the battery will pump charge to all the capacitors. So let's say have 5 electrons flows in the circuit. So these 5 electrons move and accumulate on C1 and also accumulate on C2 and also 5 electrons accumulate on C3. So the number of electrons that flowing in this circuit is about amount of the charge because Q equal to NE. Okay, so means that total charge Q total here equal to Q1 equal to Q2 equal to Q3. Okay, so the concept here is charge same. So Q total equal to Q1 equal to Q2 equal to Q3. Okay, equal to a value. Okay, then now we discuss about voltage. Okay, so what's the meaning of voltage? Work done to bring this charge from one point to another point, from one plate to another plate, right? So this is about energy. So this energy will use to move the charge across C1, C2, and C3. So that's mean energy is divided, okay, to these three capacitors. Okay, so V total equal to V1 plus V2 plus V3. V1 plus V2 plus V3. Okay, we know that C equal to Q over V means that V equal to Q over C. So we substitute this formula in this equation. Okay, so V total is Q over C, means that Q total over C total equal to V1, means that Q1 over C1 plus V2, Q2 over C2 and V3 is Q3 over C3. Okay, Q same for all capacitors, right? So Q total is a value Q. Q1 also Q. Q2 Q. And Q3 is Q. Okay, so that means 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this is equation for effective capacitance for arrangement in series. Your calculation, be careful because if you want to determine effective capacitance, actually you want to determine this. So that means C total equal to 1 over all these things, right? So 1 over C1 plus 1 over C2 plus 1 over C3. So be careful. If you want to determine effective capacitance, when you substitute all values in this equation, and then final answer should be 1 over this thing. Okay, so you can get value of effective capacitance correctly for arrangement in series. Now what will happen to all the capacitors where they are connected in parallel? Okay, so C1, C2 and C3 are connected to the power supply. Okay, so what will happen? Let's say 10 electrons move in the circuit. Okay, so this 10 electron will meet this junction, right? So have two ways to move. Okay, either to the left or upward. So maybe these 10 electrons splits in two ways, in two wires. Okay, so maybe this is about 2 electrons and this is 8 electrons. Okay, so these 8 electrons, okay, will move and meet a junction, another junction. So they can split to, maybe this is about 3 electrons and this is 5 electrons. Okay, so that means 2 electrons here accumulate on C2. So this is Q1. And these 3 electrons accumulate on C2. So this is Q2. And these 5 electrons accumulate on C3. So this is Q3. Okay, and total charge here is 10 electrons. So this is Q total. So that means Q are not same, right? So Q total equal to Q1 plus Q2 plus Q3. Voltage is about energy, right? So from this until this is about V total. So the same energy required for the charge flow through this C1, C2 and also C3. So this is V1, this is V2 and this is V3. So V same. Okay, so V total equal to V1 equal to V2 equal to V3 equal to a value V. Know that C equal to Q over V. So means that Q equal to CV. So we substitute this equation in this concept. Okay, so that's mean C total V total equal to C1 V1 plus C2 V2 plus C3 V3. Okay, and then we know that voltage all same, so that means C total V equal to C1V plus C2V plus C3V. So remaining equation is C total equal to C1 plus C2 plus C3. So this is effective capacitance or total capacitance or equivalent capacitance for capacitors are connected in parallel. To identify either the connection or arrangement in series or parallel. So look at the arrangement of that capacitors. If all the capacitors are on the same wire, C1, C2, C3, same wire, right? So C1, C2, C3. Okay, so we call as series. Okay, so charge is same for all capacitors. How's about parallel? So all capacitors are connected in different wires. Okay, so this is wire 1. Okay, connect to wire 2 and connect to another wire C3. Okay. So this is C1. This is C2. And this is C3. Okay. So all the total charge will split. Okay. At junction. Okay, so the tips here for parallel is another wire, or we can say there is junction between capacitors. For example, a circuit containing C1, C2, C3 and C4. All these capacitors are connected in series and parallel. Means that combination of series and parallel, they are connected to power supply of 10 volt. The value of C1 is 100 microfarad, C2 is about 200 microfarad, C3 is about 300 microfarad and C4 is about 400 microfarad. Now determine effective capacitance for the circuit. Okay, from the circuit, so we know that C3 and C4 are connected in series. So we combine these capacitors. So 1 over C34 equal to 1 over C3 plus 1 over C4. Okay, substitute all values. So 1 over C34 is 1 over C3 is 300 micro, right? So 300 exponent negative 6 farad plus 1 over C4 is about 400 micro farad. Okay, so C34 is 1.71 exponent negative 4 farad. Okay, so the combination should be like this. Okay, so C4 and C3 combine become this C34. So value of this 34 is this 1.71 exponent negative 4 farad. And now look at this circuit. Okay, C34 that we combined before. Okay, so C2 and C1. So all these capacitors are connected in parallel, right? So combine all these capacitance. So C effective capacitance is C1 plus C2 plus C3, 4. Okay. So substitute all values. C1 is about 100 microfarad. So negative 6 plus C2. Okay, so C2 is 200 exponent negative 6 farad, and plus C3 is 1.71 exponent negative 4 farad. So C effective should be 4.71 exponent negative 4 farad. Okay, so this is final answer. Or you can calculate step by step. So that's mean you combine the capacitors C34 and C2. Okay, so parallel. So the circuit should be like this. Okay, C34 and C2. Okay, they are parallel. So this is parallel. So you will get this combination C234, and then this C234 combined with C1. Okay, so C234 combined with C1 as parallel. Okay, and then become this. Okay, so this is 1, 2, 3, 4. Okay, so equal to effective capacitance. So until only a C in a circuit. Okay, closer to the power supply. Okay, so you compress in the simply word that we can say that we compress the capacitors to the power supply. Okay, we combine from the furthest capacitor from the power supply until close to the power supply. So very simple technique. Okay, first must identify which capacitors are connected in series or parallel. So step to combine this capacitor is start from capacitors that furthest from the power supply. Okay, and then compress until become a loop. Okay, so very simple technique. You can do this.